No, it's 5:30.
No, I'm talking.
Oh. Something else?
Is there no open gym?
Well,
There is open gym on
watching the
Sunday,
Daisy
but
game?
remember, that's a lot of kids.
Varsity don't start till 7:30.
But yes, there is math open gym on Sunday.
I'm going out. Socializing with the.
Okay,
Are you weird?
here we go. Picking up where we left off. We're on our review sheet. We're ready for number 15, I believe. So we've got this equation, and we are graphing it. And it says, find the x-intercepts. What's the other word for x-intercepts? Zeros. And it's where we cross the x-axis, right? And those come directly from the factors, so that's easy. I've got one at 2, and I've got one at 4. Find the y-intercept. How do we find a y-intercept? Oh, we talked about this yesterday. We did a couple problems. How do we find the y-intercept? We let x be 0. Kids, this is the third problem that we've had. You need to know that. You need to know that. To find a y-intercept, we let x be 0, which will be -2, and then 16. Oh my goodness, -32 down here somewhere. -32. All right. At what point is the curve tangent to the x-axis? Now, this is a perfect example of a problem you know how to do, but that vocabulary is a little different to you. We've been calling them bounce off. Remember, when the curve hits this point, it can do one of two things. It can go straight through, or it can bounce off. What makes a point bounce? A squared factor. So where do we bounce off? Where are we tangent? At 4, 0. So this is going to be the tangent point, or what we have been calling the bounce off. So keep in mind, this is going to be an exam question, so keep in mind that when they say where is the curve tangent, what it means is where does it just bounce off? Now you're not graphing that whole thing. You're identifying the y-intercept, you're identifying the zeros, and then you're noticing that because of the squared, this one is a tangent or a bounce off. Find the inverse. We already did one like this yesterday. Remember, there are some steps we go through. What are the steps we go through to find this, David?
X and the Y.
Yep, change the x and the y. And then?
Add the dividend.
Yep, get y by itself. So do the math. Yep, so we're going to add 5. And then divide by -2. Right? It's going to be a multiple choice question, so it might look like that, but it might also use the inverse notation. So don't be freaked out by that. That just means I found the inverse. Okay. Next, so now we are going to sketch. So you're going to sketch this thing. What's the first thing you're probably going to want to do with that right there? Factor that. Please be careful when you factor. Step 1 is always looking for a GCF. Is there a greatest common factor with these two terms? X. So out comes the X. And then what would I be left with? X squared minus 9. Oh, which factors, right? X minus 3, x plus 3. Right? So where are the dots on my x-axis now? Where are my zeros? At 0, at -3, and at +3. This is a cubic problem. Cubes start down here, right? Am I going to be any tangent points here? Am I going to have any bounce off points here? No. So I'm going to start down here because it's a cube. And I'm just going to pass through all of those and just shoot right up just like that. There it is. PRRs. Possible rational roots. This should be such an easy question for you. Don't forget the plus or minus. PRRs, plus or minus, then 6, 3, 2, and 1, over 3 and 1. Factors of last over factors of first, right? So what that means is, in most of our other problems, we didn't have this. So if this is all we had, our factors would be 6, 3, 2, and 1, right? All over 1. But now we also have to think about 6 over 3, which is 2, 3 over 3, which is 1, but 2 over 3 and 1 over 3. All of the factors of 6, each one of those numbers, over each one of these numbers. So that would include a couple of fractions as your PRRs. Now find the roots. These are the possible ones right here. How are we going to find the roots? Synthetic division? What do you want to try first? Alright, I heard 2. Oh, somebody says you can group that. I think I love you. Yes, you can indeed group it. Do you have to group it? No. You guessed 2, and actually 2 was a factor. In a minute I'll group it. But since I started this way, what's left?
3x squared
Minus 3. Does that factor? Ooh, I think I can take out a 3. Oh my goodness. And when I take out a 3, what happens? You can factor that. So my job was to find all of the roots. Tell me what x equals. What does x actually equal?
1.
And 2. Don't forget that guy that you guessed. Now, those of you that from the beginning said we can group this, let's do that real quick. Obviously, you don't have to do it both ways. So this will work. This will always work. Synthetic division will always work. Grouping sometimes works and sometimes doesn't. I'm going to go ahead and take a 3 out of the whole shebang. And then I'll take an x squared out of here. And a -1. Oops. And a -1 out of the second part. And you are right, it factors. See how we're going to get exactly the same answers? So if you can do that, that's super. That is super. All right, right here, we're skipping a whole bunch now. Don't worry. We got a page of substitutions coming up here. But we skipped several. Now we're on number 25. Write the equation of the line through these 2 points. What do we do first? We're writing the equation of the line. Find the slope. 11 minus 1, 3 minus -2. get 2. Positive 2. Now what? You're not done. Don't stop. Pick a point. I'll use this one. Y minus 11 equals 2x minus 3. Y minus the y coordinate equals m times x minus the x coordinate. That's called point slope. So y minus 11 equals 2x minus 6, and y equals 2x plus 5. Please get that question right. That's also on the first year algebra exam, so we want to make sure we get it right. Simplify. Got some I's in this problem. How do we start the simplification? FOIL? Absolutely. So 12 plus 6i minus 4i minus 2i squared. Remember, when you multiply I times 2i, you get 2i squared. So that's just foiling. Now what? Hey, Liam, sit up and keep your eyes open, sweetie. Gavin? We're going to combine like terms, so these are like terms. What do I do with that I squared? It's negative 1. So this would actually become positive 2. Everybody remember that?
Yeah.
Then the 12 and the 2 now are like terms. So we have 14 plus 2i as our final answer.
Is that one of the multiple choice questions?
Okay. Maybe we could write on the exam. Do we have to have another? Okay.
All right. So number 27, the little star there means it's a calculator problem. Find the final cost of an item if the original price is $32.50 and we're going to multiply by a 20% discount and a 7% tax. So when I write my problem down, I remind myself a discount is minus money off. A tax is an add-on plus. So what do I multiply by?
0.20.
No. I multiply by 0.8. It's 1 minus 20% and 1 plus 7%. So 1.07. Do not ever use the actual percentage in the problem. It's always 1 plus the percentage or 1 minus the percentage. Then we just type it in on our calculator. It is a money problem, so we'll round it off to the nearest cent. And I got 27.82. Oh, 28, we can do this, we just did it. Right?
Right.
We just did this. What's our strategy? Factor. And we have got to factor correctly. So go ahead and go with your gut feeling, but then after you write it down, what you think the factoring is, foil it back together and make sure it works. You cannot get the right answer if you don't factor it correctly, so make sure you factor it correctly. Here's my number line. Where are my dots? At negative 1 and 7. So we'll pick a number. 0, I like 0. 0's in here. So I'm checking to see if I'm going to shade in here or not. So if I put in 0, I I get negative 7 times 1, if I put zeros in. Is negative 7 times 1 bigger than 0? No. So that isn't shaded, but these are.
Yep.
So multiple choice question, the answer might look like this, right? Because that is the answer. Or the answer might look like this. So you know I've been writing down both every time because I want you to be comfortable with both even though you don't have to use both. Oh, here we go. Oh my goodness. How much of orange juice and all that. So we know our format. A lot of people miss this on the test. Blows my mind. You gotta get this right. So we know that's gonna be the setup. Before I fill in any blank, you have done enough of these to know that you're gonna go through and you're gonna start sticking numbers in. And there's always one extra parentheses that doesn't have anything in it. If the extra parentheses is here, it's number minus x. If the extra parentheses is here, it's number plus x. Period. That never changes. So let's see where the empty blank is. How much 15% should be mixed with 18 gallons of 20% to get a mixture that is 16%? So there's the empty blank, right? There's always one. There it is. What goes in there? The number plus x. So it's 18 plus x. X plus 18. Amount, amount, amount. Okay, let me just work it out. Got a star by it because it's a calculator problem too. I got 72 gallons. Okay? Those never change. Do not miss that. Those are always exactly the same. Okay, now we got an exponent. Like most kinds of problems, you've got choices about how you start here. What would you like to do to get started? You can square everything. Absolutely, you can square everything. So I'm going to leave everything right where it's at and just square everything. So that's going to be 9x to the negative 6th. Remember, when we raise a power to a power, we multiply. So that's x to the negative 6, y to the 14, z to the negative 4, over 16. You're squaring 4. That's not an exponent, that's a number. You're squaring it. X to the 10th, y to the 4th, z to the negative 10. All right, so that takes care of squaring everything. Now what? You gotta flip the negatives. Anything that's negative, so I'm gonna circle them. Anything that's negative has to go to the other part of the fraction.
Yeah.
So, my 9 and my 16. Now, this x right here has to come down. But when it comes, how many x's are down here already? 10. I'm bringing down 6 more. So I'm going to have x to the 16th on the bottom. There are 10 sitting down here. 6 more are going to drop down. So you've got 16. Now, are these guys moving? No, they're just canceling. You have 14 y's on the top and 4 y's on the bottom. So what happens to them? Y to the 10th on the top. There's 10 more y's on the top than there are on the bottom. Now, this is a little tricky because this is going up, so z to the 10th is going up, and z to the 4th is coming down. Then, once I get them moved, I can cancel them and see that I'm going to have 6 extra z's on the top. If you try to do a whole bunch at once, that's problem's hard. But if you take one step at a time, you can do it. It's not hard. Name the property. What do we got going on here? Name the property. A. Commutative of addition. Very, very good. Commutative switches the order. And that's exactly what happened. What's B? Distributive. Distributive. What's C? Additive identity. Very good. Additive identity. And what's D? Associative of addition. Now, I will tell you there is only one property question on the exam, but there is a property question, and it will be one of those properties. All right, and then we've got the infamous box problem. This is on the exam. If you do not have or know how to use your graphing calculator, you will not get this problem correct. You can get part of it correct. Down at the bottom, I drew the picture. Paper is 11 by 15. We're cutting out corners. We haven't done this in a long time, but do you remember this?
Yeah.
Oh, yeah. Part A. This is a multi-part question. Part A. Write an expression for the volume of the box. Volume equals. What is your formula for the volume of a box? David.
In parentheses 11 minus 2x parentheses times, in parentheses 15 minus 2x parentheses times x.
Beautiful. Length times width times height. Remember? It's 11, but you're cutting an x off both sides, so it's 11 minus 2x. 15 minus 2x. And then these get folded up, so the height of the box is actually x. Now, on the exam, the dimensions aren't going to be 11 and 15. They're going to be other numbers, but isn't the format of that going to be exactly the same? Yeah, don't miss that. That should be easy. Now, also easy is the domain question, because the domain is always the same. What's the lower boundary here for the domain? What is it? 0. X can't be smaller than 0. You can't cut out -1 inches. That's always 0. What's this one?
Half of the larger number.
Half of the smaller one.
Oh.
Half of the smaller dimension. So the smaller dimension is 11. Remember, you're taking a piece off each side of 11. So the most you could take off would be half of 11. That's your domain. So on the exam, if this is 18 and this is 20, your equation for volume is going to be 18 minus 2x, 20 minus 2x, and x. Your domain is going to be 0 less than x less than 9. Why 9? half the smaller dimension. So that part is simple. Now, the next part says, graph it and then find the X that maximizes the volume. So, we're going to draw a picture of this. And X min and X max are right there. You already did that part. So when you set your window, anytime you're graphing, you have to set your window. When you set your window, you've got it already. Now, does anybody remember about Y min? Y is volume. What's the minimum volume you can have? 0. Never changes. Minimum volume 0. Can't have negative cubic inches. And then remember what we do with Y max? What do we do with Y max? We guess, right? Because when we press graph, what do we have to see?
The top.
The top of the hill. So we might guess a number that's not big enough. That's okay. We'll just go back and guess a bigger one. But I'm going to guess, I'm going to guess 300 and see what happens. Now I'm going to put in my equation. This is my equation right here. And remember, we put it in with the parentheses. Oh, 300 worked. Lots of numbers would work. There's nothing special about 300. It was a random guess. All right, then what do? We got to find this point right here. That's the point we're looking for. We're going to find that maximum point. So remember, second calc, down to maximum. Move the cursor over here somewhere. Press enter. Move the cursor over here somewhere. Press enter. And then put it up there in the middle. And my maximum is 2.09, comma 154.23. We have to answer the question. What the answer to the question is going to be one of these two numbers. What does this number stand for? That is the X coordinate. What does X stand for? The size of the cutouts. So if the question is how big should the cutouts be, the answer is 2.09 inches. What is the Y value? The volume. So if the question is what is the maximum volume, then the answer is 154.23 cubic inches. So what was the question? The size of the notch. So the answer is 2.09 inches.
Why did you write 154.23 like that? Like with the parentheses in between the two?
I just ran out of room.
Oh.
I built the parentheses before I filled the number in. When we did these back in whenever that was, I told you it's on the exam. It's on the exam. This is one of the big time pre-calculus problems. It's got to be on the exam. All right, now I have a page of addendum problems because the worksheet I had to go back and cross out all the chapter 3 stuff, but I had add in the chapter 4 stuff. So here are our chapter 4 questions. There are only 7 of them. Sketch y equals 2 sine x and show labels. Oh boy. Who remembers? We're sketching y equals 2 sine x, correct?
The height is 2 and negative.
So the amplitude, we call it, the amplitude is 2. So whatever this number is, that's how up and high, up and down I'm going to go. What does a sine curve look like? It's the one that starts here and goes up and down like this. Right? We got to have our marks on here. And what are those under normal circumstances? 90, 180, 270, 360. Those are the normal marks. Guess what? There's nothing in there to change that, so it's going to stay 90, 180, 270, 360. If there had been a number in here, it would divide all of these, but there isn't one, so that's it. That's the picture. And this is what I mean by the labels. Those are your labels. This is a no calculator problem. It's kind of hard. This means somewhere out there, there is an angle. Remember that triangle? How many millions of those have we drawn, right? Somewhere out there, there's an angle whose sine is √3/2. This is the sine value. It's √3/2. Why did I put the √3 and the 2 there? Because this is opposite and this is hypotenuse, and that's what sine is. Can you tell me how big this angle is right here? This is the answer to the question. How do we know it's a 60? You're right, but how do we know that? It's opposite the √3. So the answer to the question is 60 degrees. So your job was to find the angle that had that as its sine fraction. What do we do here? So think of this as a degree measure first. So 180 divided by 3 is 60. Times 4 is 240. Now remember, this is how we label our angles. So wouldn't 240 be all the way around here like this? And then butterfly bow tie it. And then figure out if all the way to here is 240, how much is this right here? This is the key right here. How much is that? Subtract it from 180. So 240 minus 180 would be 60. Think about it. If you were at 180 and you went 60 more, wouldn't you be at 240?
Yeah.
And you just got done telling me that in a 30, 60, 90 triangle, the √3 is across from the 60. What am I going to caution you about? Negatives. Negatives. We're not in quadrant 1 anymore, so we got to make them negative, right? Those are both negative. We want cosine. Here's your angle. This is your angle. What's cosine? Adjacent over hypotenuse, so the answer is -1/2. Well, no, they're spread out more than this, but you'll also be able to, I mean, you can write all over the test. I don't recall kids having trouble with space. All right. Oh, this is not even a trigonometry question. This is just write the equation of the curve. Okay. So how do we start this? Where do we begin? With the zeros. That's exactly right. Or the x-intercepts, right?
Yeah.
Okay, so we know we're going to have parentheses. Where are our parentheses going to be? X plus 3, X plus 1, X minus 2. This is the part now that we sometimes forget. Look at the picture very carefully. Are any of these going to be squared?
Yes.
Look for those tangent points. Like right there's one, a bounce off.
Yeah.
So that means the plus 1 is going to get a squared. And so is the minus 2 going to get a squared.
Yeah.
All right. We're only half done, because what are we missing? We're missing that number. And we're going to find that number by plugging in 10 for y and 1 for x. So we have 4, 4, and 1. So 10 equals 16n, and n equals 5/8. And remember what I always warned you about? 5/8 is not the answer. The equation is the answer. Change 17 pi over 10 to degrees. Oh, that's easy. You already did one like that. 17 pi over 10. What's pi?
180.
180. Divided by 10 is 18. So we have to take 17 times 18. I got 306. Is that right?
Yeah. Yeah. Yeah.
Now we got a couple of calculator problems. Kind of hurry, and I want to get them both done.
Okay.
Find the height of a flagpole. Remember these problems? Find the height of a flagpole. If a bird on the top of the pole spots a worm 63 feet from the base of the pole. So where does the 63 go? The worm is 63 feet from the base of the pole. So isn't this 63? The angle of depression is 17.5. Always goes there, right? And the height of the flagpole is the question. So is everybody comfortable with the way I've labeled those numbers? So then you pick a function. Sine, cosine, or tangent. Tangent. Because this is opposite and adjacent. So tan 17 and a half equals opposite over adjacent. So x equals 63 tan 17 and a half. If you are using someone else's calculator, or you've loaned it or borrowed it or something, please make sure you're set in degrees. I got 19.86 feet. Does that ring some bells? All right, last one. Then we all have been through the whole exam. The height of a ball above the ground is given by this formula. So, not making you memorize it. I've given you the formula. What is, find the maximum height, and when does it reach the maximum height? So find the maximum height, when does it reach the maximum height? What shape is this equation if you graphed it? That's a parabola opening down, isn't it? Because of the negative. So if we want to find the maximum height, aren't we really just looking for the vertex? And the easiest way to find the vertex is to use our formula, which is negative b over 2a. So I got 2. So this is the point 2 comma something. You with me, gang? How do I find the something? Plug that 2 in. Remember, you square first, so it's negative 16 times 4 plus 64 times 2 plus 2. You do have a calculator on this problem to help you with this, if you need help with it. I got 66. So it's a 2-part question. Let's make sure we answer the question. The first one says, find the maximum height. What is the maximum height? 66 feet, right? So max height, 66 feet. When does it reach the maximum height? 2 seconds. This is the, when it reaches the time, and this is the height. This is the seconds, this is the feet. Okay? So, you just, between yesterday and today, you finished the entire exam. So tonight, we will be doing the second review sheet. And then tomorrow, or